Hello everyone and welcome to Software Engineering. In this lecture we are going to do an introduction to Git, the revision control system that is at the center of most modern software development projects. We're going to see how critical and crucial Git is to the successful implementation of software, the creation of new features, how Git enables us to configuration control our source code, to create different branches, to store different binaries, different artifacts on different branches within the same repository, and also to facilitate a collaborative way of working together as software developers, testers, and creators. Git is the most prevalent version control system in existence today, but it builds on a history of tools which have come before Git. In my generation, when I first started as a software engineer, I used tools such as ClearCase or CVS. And you may have heard of some of these tools in your journey with software development. Some companies still use these tools today because they've started their software development 20, 30 years ago using those tools and haven't yet migrated to more modern Git-based systems. So it may be that as you go into the workplace, you do come across legacy revision control systems such as CVS or ClearCase or others that are similar clones to those tools. But today we're looking at Git, and this lecture serves as an introduction to Git. We're going to look at the implementation of Git commands in a cloud-based system called GitLab. In practice, we'll see that there are 4 major Git-based cloud systems in existence today, starting with GitLab. Then there's GitHub, which is a Microsoft-owned solution. There is Azure DevOps, which is also Microsoft-owned. And there is Bitbucket from the company called Atlassian. I'll be showing GitLab today as the tool around which we build our applications and demonstrate the Git commands. Almost everything I say can be equally applied to GitHub and to Bitbucket and to Azure DevOps. There are some differences which I'll touch on during the course of this lecture. So we're going to look today at what is Git. We're going to look at something called Git flow and see how Git flows in operation, from starting code to maintaining, developing, testing code. As I say, we're going to look at the cloud-based solutions that are often used with Git and the distributed way of versioning our software. We're going to look at some common Git tools, both on the command line and in the cloud, and some basic Git commands, how to push, how to pull, how to commit, and what those terms mean, how to effectively construct Git messages in commits, and the importance of standardization around things like Git messages, and also the terminology around merge and pull requests, often referred to as MRs or PRs. So that's today's lecture, and it's very practical. I'll be diving into a couple of tools and showing these in operation. Git, as I say, is the most modern revision control system and almost ubiquitous in its use. Everybody uses Git today, certainly for new projects and new companies that I've come across in recent months and years. Almost invariably are using Git as the revision control system, the file storage system. In some cases, together with cloud-based solutions like GitLab and GitHub, they're also using to store files, artifacts, binaries, release management as well, also comes within this domain. Often, learning Git is part of a bigger workflow. Once the software project has been planned, the organization is managed, the work is managed through projects, the work is planned and tracked, maybe with Jira or a similar tool to what we've looked at on software engineering. Then we get to the creation phase, and as soon as we start to create software, it's a very good idea that we start using Git to revision control and store the creation of the project as we go. It supports highly iterative development. It's very easy in Git to do a diff between a particular version of the software as it stands today and historical versions of the project, and we'll see a couple of tools that you use to do that. As I say, it's a great way of managing your code, sharing your code with colleagues or with your assessors, with your lecturers, or with your stakeholders, with your customers as well. Git can also be used to build your pipeline and your continuous integration or continuous delivery or CI/CD pipeline that builds and verifies and deploys your app. We will consider CI/CD in the advanced lecture for Git, so we will consider that as a second stage. We'll also see how we can secure our applications using Git and GitLab's infrastructure and workflow, how we can deploy containers into GitLab and the container registry, permissions, settings, how we can release our application, how we can manage the infrastructure that we're using to build our software on, and also how we can use GitLab or GitHub to monitor our applications and analyze the usage of our system. We're going to look at the key features, and we've already touched on the importance of version control, but we'll see that time and time again in some examples that we talk about today, as well as a comparison of other systems that are in use today and historically. So this is to reinforce what we've just said. There are 4 cloud-based systems in operation that use Git. We will almost exclusively talk about GitHub and GitLab. To all intents and purposes, the terminology used is the same between those 2 systems. However, GitLab uses terms such as merge request, whereas GitHub calls it a pull request, and GitHub actions are the terminology of steps in a CI/CD pipeline, whereas we would just refer to those as steps in a GitLab CI/CD YAML file in GitLab. So there are some differences, but to all intents and purposes, these terms are equivalent between the systems. On this course, we recommend that you install the Microsoft Visual Code Editor, or if you've attached yourself to a different editor, such as VI or Eclipse, they're also fine. Any fully featured editor or IDE which has a Git integration is what we would recommend. And there seems to be a standardization in the industry, I would say, around Microsoft VS Code, as that it has a number of extensions around Git and also around syntax highlighting of the language that you've chosen to implement your project in. And it's a very full-featured environment that enables you to auto-commit code as well from directly from the editor when you've made changes. We also recommend you install Git Bash just to try out some of these commands, even if most of the Git commands are abstracted in the cloud-based IDE and you can actually drive them through buttons in the IDE. We still think it's of value that you learn on the command line how these commands actually work so that you can access them under the hood, and you can see what's happening under the hood when you're doing things in the GUI. There's that understanding that you've got because you've tried these commands out on the command line. We also recommend, if you haven't already done so, to create an account on GitHub or GitLab using your University of Bath email address. In fact, let me just jump to that point and show you how to do that. If you go to gitlab.com that you can see here, go to the users, go to the sign in page. There are different options to sign in if you already have an account, as I do. Your username is usually your primary email. I've also chosen the username NRL30, which is an abbreviation of my email. But choose your full primary email associated with your University of Bath account. Choose a good, strong, unbreakable password, and then sign in. Or you can create an account directly from your Google email address, your GitHub handle, or Bitbucket, or Salesforce. There's different ways of creating an account. Or you can register using the register option here to create that new account. Once you have it, you will be prompted usually to go through some security step, a captcha, just to show that you're not a robot. But once you've done that, you'll see an interface like this to create your first GitLab project. And as I say, almost all of this applies to GitHub as well. On the left-hand side, you see groups, issues, merge requests, and the concept of milestones. We'll talk about the other options later. But for now, if you can create your first project, go to New Project here. And you have the option to create from a template. You have the option to add CI/CD to another repository, but run GitLab CI/CD pipelines for, say, a GitHub project. So maybe you've got project code stored somewhere else, but you want to run your pipeline in GitLab. that's possible. That would be this option. You can migrate your data from an existing source such as GitHub, Bitbucket, or another instance of GitLab. Here I'm using the cloud edition of GitLab. However, there are self-hosted versions available. So often if you go into a company, perhaps in your placement year or following your graduation, you may join a company that's using a self-hosted GitLab, and that will look like this, but won't be hosted on the cloud. You'll have your own domain, mycompany.gitlab.com usually, and that will be self-hosted. So for now, I would either choose a blank project or create from template. If I show the create from template, you've got different options if you were creating a Ruby on Rails project, for example, a Spring project, which would have the MVC, the view controller, microcontroller architecture. If you're creating a Node.js project, there's a template there, or an iOS app, then you have a ready to go Swift application. .NET Core is also supported in the templates, as is Android. And there are dozens more. If you're creating a Go project, if you're creating plain HTML or Netify, Salesforce DX for extending Salesforce development, cluster management for Kubernetes, that's something we cover in the DevOps lecture, or a Kotlin native Linux application also. There are also more templates available online that you can create and you can load into here. For now, I'm going to just go back actually to a new project, and I'm going to create a blank project to give me complete control. And what I'm going to do here is I'm going to create, for the purposes of just teaching you Git on this course, I'm just going to create a math library or maths library. And so this is my project, and it's going to create the project URL here. I'm going to put it into an existing group that I've got for software engineering. So that's something I already created. And I've got some optional choices here for the project deployment target, which I'm just going to leave blank at this stage. And I'm going to create this math library. And I'm going to initialize the repository with a README so that I have at least one file in the project. And I'm going to create the project now. So this will do the equivalent of git init. So if I flick to the slides, git init is really the first step. Once we have a working directory, we're going to be committing, pushing, and pulling, and we're going to be cloning a repository, and we will go through all of each of these commands. But the first step is really git init and git config. So git config on the command line will set your username and your user email, and this will appear in your git commits, and we'll see how this gets configured. So this is the git config command, and then git init to initialize the repository, and then git clone to clone the repository. So the init step is actually being done by the creation of that project in GitLab in this case. So I've got my maths library project. The project's been successfully created, and I have an initial commit of this project, which I've just authored, and you can see I'm the author here. This is the amazing thing about using Git in the cloud. You have a lot more data. Your whole Git process is really managed here, although as we'll see on the command line, we can do different things that improve our productivity. So here I can actually clone the repository, and I can clone with SSH, or I can clone with HTTPS. And that brings me on to the topic of authentication. You don't want that anybody can access your GitLab repository. Access is tightly controlled, and you need to authenticate to be able to push to your repository. By the way, pushing just means sending any data locally to my instance. Git is a distributed version control system. So you can think of it as being centrally stored code and artifacts. We then, as users, push our code from our local branches, our local work, to that centralized repository. So you've got a distributed architecture, but you want to authenticate that communication from your local branch to the cloud base. That's done through SSH or through HTTPS. On this course, we're recommending SSH to do your cloning. And if you go to settings are up here, and you'll see preferences. You can see there is a section for SSH keys, and in this case I have no SSH keys with access to my account. We recommend you install the tool Git Bash to give you command line access to Git. And Git Bash is a Bash Unix style environment. It has many other useful tools as well, but it has the essential tools that we need to do pushing and pulling and also creation of SSH keys. So I'm going to teach you now to create an SSH key and add it to your Git repository. So firstly, once you've installed Git Bash, I'm just going to bring Git Bash up from my start menu. There is a special command that you use to generate a key. It's called SSH keygen. And if I run that, it then generates a public private RSA. That's the Reverse Shamir Adelman algorithm for public key cryptography. And you essentially give your public key to GitLab, and you retain your private key, and it does the authentication, the handshake, and checking that they match. So I'm just going to call this, let's call this software engineering key. I can add a passphrase to give me extra security and extra randomness in the generation of the key. You may want to do that. Certainly for higher security thresholds, I would advise that. For now, I'm not going to give a passphrase. I'm going to let it generate for me a key. And you can see here that it's generated something called swe_key.pub. That's my public key for GitLab. And if I just use an editor here, I should find that key has been generated. It looks a bit like this. It's just a single line of text. And if I copy this, it starts with SSH RSA. I can copy this to my buffer. I can exit the SSH keygen, and I can add that new key to GitLab in this case, and it's populated the fields for me, and it's added a key. And I've set an expiration date of about a year from now. And I'm going to add that key here. And you can see the key's been created. It's not been used yet. It expires next year. And you might want to set a shorter expiry date so that forces you to regenerate a key. That's good key management, actually, with Git, that you don't have a years long key, but you just have a couple of months. For the purposes of this demo, I'll keep it to a year. And you can see it's an SHA-256 authentication, and MD5 is also given there in the fingerprint, and the key has been successfully added. What that means now is if I go back to my projects, and in the key management, I can also delete the key that I've established. I can see my handle here is Neil Langmead Bath Uni. I've got no Git activity that's stored. As I do things in Git, you'll see commits, you'll see this activity chart getting populated. If I do, I think something like 20, more than 30 commits, 30 plus contributions a day, then you'll see a darker square, and you'll see slightly lighter for 20 to 29, and 0 to 10, 1 to 9, sorry, is the lightest color. So you can easily see when your heaviest commits have been. Some people use this as a productivity tool to see how frequently people are committing to Git. So we've added our SSH key to GitLab, and now we're back in the maths library project. Because I've added the key, I can now go to clone this code for the first time, and I'm going to clone with SSH. So I'm going to copy the clone command. Then I'm going to my Git Bash shell, and I'm in my Bath University directory, and this directory is going to be my working directory, and I'm going to use the first command, which is git clone, and then paste the cloned address of the maths library. So what does this mean? So Git is a centralized repository system, as we've discussed. This is fetching the code from the centralized repository that's stored in GitLab and bringing it to my local machine. Git clone and then the git@gitlab.com is the Git repository address of the remote repository, and it's going to go and get the maths library for us. And you can see it's starting to copy and pull the code down from the remote server. And this is an empty project, so it's a fairly quick process. So that's our first clone. Now I want to work with GitLab to create something called issues, and we'll see why we do this later. But we want to eventually link the code that we're working on and the branches that we're working on to issues or features. So in this simple example, I'm going to go and essentially create some requirements for this math library. I'm going to create a new issue that is number one. We're going to add create a function, C function, to add two integers together. And I can use the facilities of GitLab to give myself more information. The function shall handle minimum and maximum amounts correctly according to system limits. For example, I can assign the issue to myself. I can associate that with a milestone. We don't do that in this particular example, but I want a C function to create, to return and create two integers. The return shall be the sum of the two inputted integers. Okay, so a very simple requirement. That's a new issue, and we'll see why that's really important for traceability later. I've created an issue, and then at the same time I want to create a merge request. Okay, so when we create a merge request in GitLab or a pull request in GitHub, that will automatically create a branch for us. In fact, you can see now we have a branch called one-create a C function to add two integers together. Okay. Also, you'll see that there is an automatic closing of this issue in the description. So the idea is when we have an issue, we create a branch to work on that issue. And then once we're done, we've implemented the feature described in that issue, we will create a merge request requesting to merge this into our main branch of our project. And then once that takes place successfully, we've merged, the issue will then close. So we get a round trip traceability between issue creation, branch creation, implementation, testing, and then merging, and then we'll get closure of the issue. Okay, so I'm going to assign this merge request to myself as well. And you can see GitLab's put draft and resolve in the title. This is important for later because sometimes when we have a DevOps pipeline that runs, we don't want it to run with every commit or with every merge request. We only want to start running the pipeline maybe once we've achieved release maturity. And so by default, GitLab won't run CI/CD pipelines on merge requests that are labeled with draft or resolve. So that stops any pipelines running, which saves some resources. That's the reason for that. So once we've created this merge request, you can see now I have a request to merge this newly created branch into the main branch. And main is what GitHub, GitLab, and Git generally uses to describe the main line of where our integration target is. So we're trying to merge work that we've done locally in branches into the main branch of Git. Historically it used to be called master, it's now called main. So on the remote server, we now have an issue to add two numbers together in our new math library, and we also have a merge request to merge that into our main branch. However, that's all on the server here, on the GitLab server. How do we bring that locally? If I go down to my Git client and do git pull, we should see, if I go into the correct directory, to the maths library. Oh yes, when you do a git pull, it pulls or git clone, sorry, it pulls the code into the directory that you see. It creates that directory. So I need to first of all step into that directory, and then I can use the reverse search feature of git bash to do a git pull, or I can just type git pull and it will correctly see that on the server we have a new branch called create a C function to add two numbers together. That's this branch, and I have pulled it down. I now need to change to that branch. So locally I'm still on the main branch here. I now need to change to this new branch, and the way we do that is we do git checkout, and then we can do one and then dash tab, and when we do a tab it will complete and find the name of the correct branch. And as we do that, you'll see, if I just make this a little bit bigger, we're now no longer on the main branch, we are on this new branch that we've created. And Git is helpfully instructing us where we are in the hierarchy, where we are on the tree. We can see which branch we're working on at all times. So now I'm going to go ahead and I'm going to create a function that adds two numbers together, i.e. I'm going to implement the feature, and I'm going to then proceed to the next Git commands. So I'm going to just create a function called add two numbers as a C function, and I'm going to do int add two numbers together. Int x and int y are my initial parameters, and I'm just going to, at this stage, return x plus y as my function. Okay, so that's my first version, and I'm going to save the file. And the next Git command that we're going to use is called git add, which will add this new file to my local branch, to my local repository. And the way we do that is with git add. So I'm going to do git add, and I'm just going to use the shortcut here, pling $, which is the previous file that we've edited, the previous argument of the previous line, and it will then go and add my add2numbers.c to my local branch. Now I want to commit this code to the branch with a message, and the way we do that is with git commit. So I'm going to run git commit, and there is a parameter called -m, and -m is the message parameter, and I'm going to give this a message. And what I'm going to do, a lot of people use a naming convention, that I'm going to put the issue name in the commit message just for traceability, so I can trace the local commit to the issue that I've created. So I'm going to do that. It's issue number 1, and I have maybe a good convention that the commit message is short. It's less than 80 characters. It describes the main thing that I've done in this branch, and it could form the release notes. We know some companies, for example, that would automatically scan the git commit logs for the release notes. And so if you phrase it in a careful way, you can save yourself work with other parts of the software development lifecycle. So I'm just going to write added function to add two numbers together. That's my commit message. And you can see the git response to that has created that commit. And then there is a git push command, which will push my locally created changes in my local branch to the cloud-based version. And you can see in the background, GitLab has responded to that push, and you can see various things happening. This commit here has been correctly registered. I've added a function together to create two numbers. Commits have a number. You can see there's a commit ID here. If I click in GitLab to that commit ID, then we've got some various useful information which will help us with code review and other activities. We can also see the changes that have been made here. We can see there's no current CI/CD pipelines running. We'll look at that in a future session. We can see the commit, that we've added two numbers together, and we've got the overview of this particular commit in the merge request. So maybe you're working collaboratively. You could share that link, you could share this diff with another user in GitLab, and you can actually use this to annotate and put your code review comments. So let me show you how to do that. Maybe you think that your code review has decided that every function should have comments and it should be documented. So I could put this as a comment here, and now imagine that I'm a secondary user. I'm just going to add a description of function. Okay, and I'm going to make a code suggestion. consider adding code comments to document feature. So I'm going to add that as a comment, and you can see that I've added that comment as part of my code review. I could actually add a code suggestion as well. So there are ways of doing that in GitLab that we'll talk about, where you can, if you're more than one person collaborating on a file, you can add not just comments, but you can add activities in the code review and then accept these changes more easily. But for now, I've added this comment. I can also address the comment to other users in my department, and they'll be tagged and they'll receive a message that I've made a comment on this code review. So let me cancel that, and I'm just going to discard the changes here. So let's think about this merge request. Is this code ready to merge? Not really. I don't have any code comments. Also, I don't have any error handling around X and Y. So let's look at the Git flow for making changes. So firstly, it's often a good idea to do a Git pull, which pulls down the latest version. Check that nobody else has committed code to the remote repository first. Here in my case, I know that's not the case, but just to make sure we're already up to date. Now I'm going to edit my file again to nums.c. I'm just going to maybe write some comments just to make it a little bit more descriptive. Function to add two numbers, integers together. Function shall return the sum. Okay, and this is moderately improving the quality of my code. So I'm going to go through the stages again to add this to and commit this to the repository. So I can do git add to add to the local branch my changed file, or I could actually do a git status. That's a good idea to run. You can see that Git has seen that I've got a modified file. My file has changed, and it's showing me that in red. So at that point, I'm going to add it to the local branch again. I'm going to do a commit. I can use the same commit message, or I could say I've improved the function in some way, and I'm going to do another push, and that will push that change to my math library, to my repository. And you can see now I should have the initial commit, and if I go to merge requests on this side, you can see now that I've got two commits with those two changes, and I've got all the diffs for this function and for the comments as well. Okay, so that's all good. Let's say now we're ready to merge this into our main line. Then what I'll do is I'll go to the merge request, and I will edit the merge request. So here I'm going to now edit this MR, and I'm going to remove the create a C function, draft and resolve, and I'm expecting that to automatically close this issue once the merge request has been accepted. I'm going to save the changes here, and we have an optional approval stage. In my particular case here, I'm the only user on this project, so I'm self-approving. However, it's good practice in your software engineering projects that you have at least one other approver for the merge request, and this gives accountability. It gives us peer review, and it ensures that there's been at least one other pair of eyes on the code before it gets merged into mainline. So you can change all of these permissions and settings in GitLab so that you can automatically configure that, for example, to reject an MR, a merge request, if that secondary approval has not yet been granted. And it kind of forces you to a good practice, a good way of working, that everything has to be reviewed. You'll also notice that before we merge, there's this option to delete the source branch and to squash commits and to edit the commit message. So you can imagine if I have more than two commits, maybe I've gone through several iterations and I've committed several different messages and different changes. This gives me the option to squash commits which is basically to just provide one commit message at the end. So I could optionally ask the system to do that, to squash commits and then edit the commit message so that there's one summary of all the changes at the end. So I'm going to do that. This is my merge commit message, and I'm going to click merge now, and you can see GitLab is going to merge my code changes into the mainline branch, and it's also successfully merged. Here are the details. I've merged it with this commit. The commits were squashed, and the source branch that I've just been working on has been deleted. So now I have a local branch called one create a C function, but I no longer have that on the remote branch because this work has finished and has been successfully merged. So just to be tidy, I would actually usually go back to the main branch and do a pull of the main branch to get the latest changes. And you can see now that I've pulled down from the main, I've got the new function, add two numbers together, and I'm basically now at my first version of my maths library, main has gone forward by one commit with this merge request or pull request merged in. So this is a practical illustration of how you can use an issue, create branches. You could do the same. Let's do the same kind of thing for either a fix. I could propose a fix to my existing feature, create a new branch for adding more data checks to the two parameters. I didn't put any data checks on the parameters, for example. So I could create an issue, add data checks to add function, and that will create issue number 2. I can assign that to me and create the issue again, just in the same way that we did before. Creating a merge request will instantly create that branch for us. Now we have issue number 2 to add data checks, and I'm going to create the merge request again. Here we've done it in the cloud. Now we do it once more, and we do a git pull locally to pull those changes back from the server, and we can see that we've got a new branch called add data checks to add function. Let me quickly go through and add those checks. So we're going to say if x is bigger than minus 10,000 and smaller than 10,000, for example, then return the summation, and maybe that's the range that we're adding. And I'm going to now just go through all the same stages. However, I'm still on the main branch. So first of all, now that I've pulled down the second branch, I need to switch to that second branch. So let me just do that first. Check out branch number 2 and do a git status. Okay, I'm going to now add my changed file, and my commit message will now have issue number 2 in the name, and I'm going to say added checks on parameters of add function. Okay, and then do a git push again to push that change to GitLab. Now you're starting to see my merge is blocked because merge request must not be draft. They must not have draft in the name. I can instantly mark it as ready, and it will change the name of the merge request, or I can use the edit up here, and I'm just going to basically just change the title to add checks to the function here. That will close issue number 2, and so I'm going to save my changes, and I'm going to it's told me that it's ready to merge. I'm now going to merge. I don't need to squash commits because I only did one commit on this particular branch, and so it's merged this now. So I've done 2 merge requests in GitLab, and if I go back to the main and do a git pull, I'll be able to pull my second change of the maths library back into my local branch. So now you're seeing the complete workflow, making local changes, creating branches, creating merge requests, and I've got traceability to the issues. So the issue here are now closed. I can see my closed issues. I have complete traceability between the issues, between the branches. I can review what code was added and changed on each branch. It's absolutely amazing tool to work with code and to work with issues and have that traceability. So let's just go back to the slides and review what we've just looked at. We've seen a working directory. When we do a git clone, we have a local directory. We change into that directory, and that's where we can do these commands that we've just done, our commit, our push, and our pull. We can also use that to understand the whole Git workflow. So we cloned a repository that we created in GitLab. We created a new branch. We recommend creating a new branch for every new feature that you develop, and this ensures that your changes are isolated and don't interfere with the work of others on the default branch. We've seen how to make changes in the working directory, to commit those changes and push those changes back to the server. We've staged those changes in Git in a merge request. We've reviewed our Git commits and our history and our commit messages. We've pushed our changes to share our changes that we've done locally with the cloud-based repository, and then we've merged our branch into the main once our changes are reviewed and approved. So we've gone through the entire very simple Git workflow just with this very simple example and this demonstration. We've seen how to manage our code, collaborate with others, and keep our projects organized with a Git workflow. These are the commands that we've used just now: git checkout, git add, git commit, git push, and git pull. You can also do this in the IDE. So if I went back to GitLab in this case, you'll see in my repository, if I click here, I have my README and I have my function. Here, I can actually edit this inline. Let's show how to do that. I can edit the file or in the web IDE, and GitHub also provides this IDE that you don't have to do that local cloning, but you can do it in VS Code inside the browser. So here I could add something else, for example, do a check on the input range should be minus through 2. Okay, as an example. Or I could do something else. I could actually improve the code and have Z, and I could say here I could do Z equals X plus Y, return Z. Okay, so make maybe some improvements here, initializing Z. And then here you can see on the left hand side, I've got my source control. I can commit and push directly to main. We don't advise that actually. The best projects actually always commit to a branch and then have this process of reviewing. But for this simple example, I could just push the committed changes to the default branch. I would actually recommend create a new branch and then merging that as we've just done. But for the sake of brevity, I'm going to click commit here, and it will then push directly in my browser. So I didn't have to work locally there at all. And if I go back to the project, back to math library, and you can see on this function, I've just committed this change to the code, and I've got an extra commit now as well to this particular function. You can see you can leverage the power of the IDE that you're working in, or you can do things locally. I have a preference for working locally, just so I can understand and follow the steps. It's also, as I say, good practice to work locally on a branch, then present that branch for review through the pull request or merge request process. So try, as you use Git in your projects and your coursework, create those branches locally, push them to a branch of the same name on the remote. That's the default of Git. And then create that pull request and invite somebody to review your code before you merge it in. Of course, you can extend the sophistication of your Git usage, and we'll be looking at that in subsequent lectures by looking at some more advanced Git commands, and also looking at how to add CI/CD pipelines, because we don't even know if this math library builds yet. So how do we do that? And we haven't come on to that yet, but obviously we want to be able to know that this software that we've committed builds, that it works correctly. So we have a concept of testing the code and adding test cases to the code. And also maybe we want to run those tests before we merge the code, and we can do a gated, what we call a gated merge, where the merge only happens if, for example, all our unit tests pass and the code successfully builds and compiles. So we'll look at that in the next lectures, how to add a CI/CD pipeline that builds and tests your code to your Git repository. And for now, that's the introduction to Git. I hope you've enjoyed it. I hope you found it of value, and we'll see you in the next lecture. Thank you.